Hello everyone. A very good morning, good evening, or good afternoon, depending on wherever you are joining me today. Today, I'm going to present my work titled SoftCare, Deep Learning-Based Smart Healthcare Framework using Softwarized IT network slicing at the 2022 Joint Telematics Group and IEEE Information Theory Society Summer School, virtually organized by Triple IT Monday. So here's our team, myself, Devoshi Basu, along with Vikram Krishna Kumar, and this project is guided by Professor Uttam Ghosh and Professor Rajan. So here's a very brief outline of our contents, and let's move into the topic in detail. As we all know that the dynamism inside the network is increasing with the existing heterogeneous environment, and also with this emerging 5G and the upcoming 6G communication network, the massive growth of the connected devices is also increasing. The digital transformation of modern digital healthcare devices generate excessive data that demand URL responses for better quality of service. That we all know. And storage, processing, and classification management of this big healthcare data is extremely complex and difficult. So, obviously, what we want is that to no compromise with the critical care situation, and that is why we are proposing a system model with always all e-healthcare services, so that we can back up the service outage situations whenever it happens. So, two technologies that has been used here, software-defined networking is and network function virtualization. So, a very brief framework has been presented here. So, in the successive slides, I'll be explaining this in detail. So, the related works and major drawbacks, and from where we have derived our fundamental motivation, is that very limited usage of the online data due to the restricted hardware resources. So, and that is why the network slicing technology has been introduced in the later part. And also, the further extensive work on machine learning-based URLs applications in e-healthcare slices shows that the very limited contributions done on the dynamic flow management in URL e-healthcare application, leveraging the concept of machine learning techniques. So, following that, we are proposing here our system model architecture for soft healthcare, where there we see that the defined healthcare slices are defined slices are there. And our main focus is on the healthcare slice, which is dedicated for the healthcare services. So there are different types of service demands coming, like EMBB, MMTC, or URL in all of the slices. And in the successive part, we'll see that how our proposed solution and flow algorithm flows. So the next slide is like the simplistic overview of our solution. So whenever the incoming traffic is coming from any mobile IoT and healthcare devices, so first, the deep learning-based neural network traffic analysis has been done on defined characteristics of the incoming traffic flow. Depending on that, a network slice manager takes a decision that whether the required e-healthcare slice is available or not. If not, then we'll be redirecting the slices to the other next best slice available. Maybe it is AM, maybe it is other EMMTC slices, maybe for vehicular, maybe for IoT dedicated slices. So that at least the traffic should flow without any interruption. So once the slice backup, once the task has been completed, there's a slice backup function has been done after the task completion. So once everything is done, then we'll receive the steady state when everything will flow apart as it was previously. So obviously, this is the simplistic workflow with an objective of save the services on the go with restricted load and latency of the network slice. So a very brief result analysis has been done. So like these are two of the steady state in the load and latency constraints, and we see that like whenever there is a service blockage with the incoming service request, so we are searching for the best slice where we can shift the data from the available e-healthcare slice, unavailable e-healthcare. So according to that, we are shifting the data from the marked region. Similarly, these two are for load and latency purposes. So what we can see is that we have developed a flexible BSD-driven programmable sliced server model for the rapid access of healthcare data on the heterogeneous IoT-assisted healthcare devices. We have seen that 9 to 15% of the reduction in the response time has been achieved. There is a limitation that this has been applied on the smaller data sets. So obviously, if we can apply it in a bigger and real-time data set, then we can improve our model further. So future work is obviously one of the things developing an economic solution with the PNF placement and also improving the network slicing architecture as well. So if you have got extended work, so currently the work we have presented here is under review. The extended version is under review at IIT Developer. And also one of the journal has been work has been completed and this paper is under preparation now. So this is our references, and thank you very much for your time and listening. So please feel free to ask any question, any suggestions on this thing, on this work, in this giving contact details. Thank you very much.